To the right of the visible spectrum, we find these types of energy that are lower in frequency and thus longer wavelength than visible light. These types of energy include infrared rays, microwaves, and this video's topic, radio waves. Radio waves have one of the largest wavelengths. These waves are used for long-range communication as they are capable of propagating along the curvature of the Earth and do not get diffracted. They are sent using the transmitter and received using the antenna called the receiver. Radio waves are widely used for long-range communication because they operate in the range of 3,000 to 300 billion frequency. Similar to other electromagnetic waves, radio waves also travel the speed of light, which are generated by fast accelerating electrons. Radio wavelengths range from a few millimeters to hundreds of kilometers. And most importantly is that radio waves are transmitted easily through the air but do not cause any damage if they are absorbed by the human body. Heinrich Hertz proved the existence of radio waves in the late 1880s. He used a spark gap attached to an induction coil and a separate spark gap on a receiving antenna. When waves created by the sparks of the coil transmitted were picked up by the receiving antenna, sparks would jump its gap as well. Hertz showed in his experiments that these signals possess all the properties of electromagnetic waves.
You can tune a radio to a specific wavelength or frequency and listen to your favorite music. The radio receives these electromagnetic radio waves and converts them to mechanical vibrations in the speaker to create the sound waves you can hear. Radio telescopes look toward the heavens to view planets, comets, giant clouds of gas and dust, stars, and galaxies. By studying the radio waves originating from these sources, astronomers can learn about their composition, structure, and motion. Radio astronomy has the advantage that sunlight, clouds, and rain do not affect observations. Since radio waves are longer than optical waves, radio telescopes are made differently than the telescopes used for visible light. Radio telescopes must be physically larger than optical telescopes in order to make images of comparable resolution. But they can be made lighter with millions of small holes cut through the dish since the long radio waves are too big to see them. If we were to look at the sky with a radio telescope tuned to 408 MHz, the sky would appear radically different from what we see in visible light. Instead of seeing point-like stars, we would see distant pulsars, storm-forming regions, and supernova remnants would dominate the night sky.